Okay, so to close out the week, we practice with the Net Change Theorem and with U substitution, both of which are going to show up on your final exam for sure. So this video will concern itself with the net change questions, and one that follows shortly will concern itself with U substitution. This helps keep the size of the videos down and also helps you to focus your review where it needs to be focused. So maybe you just need help with net change, and if that's the case, you should be really good at questions like this. So antiderivatives make me think of integrals. So if we do the integral of x squared over 1 plus x cubed dx from 1 to 4, you might ask yourself, well, how does this happen? Well, the fundamental theorem says we take some antiderivative and we substitute those two limits and subtract. Now, this we know, and that's what we're looking for. So if we knew what this was, and the calculator surely says that we do, and we know what this is, we're done. So f of 4 is this integral that a calculator will give me plus f of 1. And the calculator gives me this, and then I add 20.20, and I get 21.360, and that's it. We should be really good at stuff like this. We should be really, really skilled with this by now. Then I included a couple of application questions just for sport. And then I asked us to try to answer this question without using an antiderivative. And that's a weird thing because this is a velocity function. And so when we're trying to undo a velocity function to get back at position, we always take an antiderivative. And if you did an integral from 0 to 5, you're fine. But can we do the integral from 0 to 5 without appealing to the fundamental theorem? Well, absolutely. This is the velocity function. From 0 to 5, this integral is just the area of a trapezoid. The area of a trapezoid, the integral from 0 to 5 of the velocity function, is just the area of a trapezoid. 1/2 height, sum of the bases. The height happens to be 5, and the sum of the bases happens to be the sum of the velocity here and the velocity here. Velocity at 0, velocity at 5. And so this turns out to be 45. So the integral from 0 to 5 of the velocity function dt is 45. We know the particle's at the origin at the beginning, so where is the particle at time equals 5? It's at 45. So it's not just that the integral is the answer. The integral plus where the particle was at the beginning of the interval is the answer. And it happens that those are the same because the particle is at the origin at the beginning of this problem. The other question we should answer is this one, where we ask you to find this integral to 3 decimal places, and because we asked you to find the integral to 3 decimal places, it is not necessary to use the fundamental theorem. Your machine will be fine. It turns out that I should have paid better attention because 2 of those decimal places are zeros. So then interpret this number. Interpret the number. Well, this is in miles per hour, and this is in hours. So this is a number of miles. Miles for what? Well, it was the velocity of the Reuter family vehicle over a 3-hour period. So this integral means that the Reuter family vehicle traveled 142.5 miles over the first 3 hours over this particular 3-hour period. So when we explain this on final exam or whatnot, we use units to refer to what the answer represents, and then we put it in context. So over this 3-hour period, the Reuter family vehicle traveled 142.500 miles. And that's how we say it. Okay, these are the sorts of things that I expect us to be able to do with respect to net change. Hope they are helpful.